Hey guys, Kaushik here. Today I've got your LeetCode question where the question number is 167 and the question name is 2 sub part 2. If you haven't watched 2 sub part 1, please do not forget to watch the video and come back. Alright. Now let's try to understand what exactly is given in the question. Given an one indexed array of integer number, right? So please remember, it is not a zero indexed array, it is going to be one index. That is, the indexing starts from 1. That's not a problem. I'll tell you how to handle the issue later on. And it is going to be sorted in non-decreasing order, which is it is going to be sorted in a ascending order, right? So the difference between the previous question, that is your 2 sum part 1 and 2 sum part 2, is very simple, that the array is unsorted in part 1, whereas in part 2 it is going to be sorted. But what difference does it make? Let's try to understand. Let's just directly jump into the question and we will see what exactly it is. All right. Now, the array is given over here. Yes. And there are numbers which are in ascending order, isn't it? But what is the question? Given a target, we need two numbers. We need index of two numbers whose sum will be the target. That's the question part 1 as well, right? Yes. So here you can take 7, two numbers. We'll go with 11 and 2, isn't it? So 11 plus 2 is 13, right? How about the logics which we applied for the part 1? That is a brute force approach. Yes, it is going to work. Obviously, you will take I, you will take a J, and you will check, is it target? No. Is it target? Yes. And you will return your I and J. Brute force approach works. But the problem over here is time complexity, which is we go of n into n, that is quadratic time complexity. All right. Now, trying to understand whether hashing is going to work or not, right? We need a dictionary. And we just made a very simple math. 13 minus 2 is 11. Do we have 11 in the dictionary? We will have 11 in the dictionary because we'll create dictionary, isn't it? And we'll return the indices of 2 and 11. Not a big deal, right? Now, the problem with those two logics is the first one is going to be having high time complexity, whereas the second one is optimized, which is going to be big O of n, but it takes an extra space for the dictionary. But if it is sorted, is it possible for me to reduce or optimize it more better, right? Let's try to understand. Yes, if you observe the sorted pattern, right, the left side data sum, right, will be lesser, whereas the right side data sum will be little greater. Yes. Now observe. Let's take 2 pointers. Okay. Yeah, we are going to solve this with a 2 pointer approach. We'll take 2 pointers and check. This 15 plus 2, right? It is 17. If you observe, 17 is greater than the target. We want the value to be little lesser, right? So as we want a lesser value, let us move towards our left side. And you observe 11 plus 2, it's 13. And yes, we have found the answer, right? So let's try to understand with another example. We have another sorted array over here and the target is going to be 25. Now, if you will observe 22 plus 2, like I'm just going to take 2 pointers, I and J, and I'm going to sum these two values. 22 plus 2 is 24, which is lesser than 25. Yes, than the target. The sum value is lesser. So we need a bigger value, a greater value. So let's move towards our right. Keeping the J in the position, only I is going to move. And now check with the sum. The sum is 27. It has gone beyond the target. I mean, it's become greater than the target. I need a lesser value now, right? So let me reduce my, let's come towards my left side. I'll reduce my J value. Now check with the sum. It is going to be 23. Again, the value is less than 25. Yes. So what I'm supposed to do again is I'm going to increase the value, right? I need a bigger value. So let me just move my I over here and I'll keep my J there itself. Yes. All right. Now, 18 plus 19. Yes. So now if you observe the sum, right, it is again greater. So what I'm going to do is I'm going to move. I want lesser value. So I'm going to move my J. Yes. Keeping my J over here. Now if you check, yes, 16 plus 19 is 9. 16 plus 9 is going to 25. And yes, we have found it. I hope you understood. Let's try to code this logic. All right. Let me take L variable, which is going to be in the left side, and I'll put it as 0, right? And I'll also take R variable, which is going to be at the last, yes. And we know the index variable, it is going to be the array. Let's take the array length as num, okay? So len of nums minus 1, right? So L is over here, we'll just take L and R, right? I'll keep my L over here, R over here, right? Yes. Now, we know very well that we have to compare and keep on doing this, but we are not sure about the iterations, right? We don't know number of iterations. So obviously I will be going ahead with an while loop, but what should be the while condition? We'll decide later on, right? Checking with the first if condition, I will check whether the nums of L plus nums of R, that is, sum of these two values is equal to target, right? And if it is equal to target, we will obviously, what are we supposed to do is return the values, right? L comma R. So, but wait, they asked us, they told us very clearly that it is going to be in the array is not going to be a zero indexed array, it is going to be one indexed, isn't it? Thus, while returning, to handle that, very simple, just while returning, make it as L plus 1, R plus 1. So it is considered that we are working it as 0 indexed, but then we are replicating it as 1 indexed. All right. Now, if the condition is false, obviously the condition is false, 22 plus 2 is 24 and it is lesser, right? If the condition is false, I will go for an elif condition where I will check whether the sum value, right, is greater or lesser, right? Now that the sum value is lesser, if the sum value is less than the target, what am I supposed to do, right? If the sum value is less than target, I need to go towards the right side and check for the value, right? So I'll be moving my L. So L equals to L plus 1. So it means technically I'm going towards my right and checking for the values. And if the sum value is going to be greater, then I should come towards left side. Coming towards left side is nothing but moving your R, right? R equals to R plus, R minus 1. So you reduce your R and you increase your L. That's it, right? So we are not reducing R and increasing L at a time. They both are happening like at different times. Like the target is the sum value is greater, then the R moves to make it lesser. If the sum value is less than the target, then L moves to make it greater, and then we attain a balance situation, and then we stop over there and we directly return the answer. Yes, got the point, right, everyone? And that's it, right? And if you observe, we aren't taking any extra space. So the space complexity is going to remain big O of 1 itself, and the time complexity will also reduce because for in every array, we will be doing half of the iteration. So it is going to be again linear, but the space is optimized, isn't it? Try to write the same code, but yes, we haven't mentioned the condition yet here, right? When I'm going to stop doing this, or till what time I'm going to keep on doing this. Yes, I am going to keep on doing this until my L is less than R. That is, my L is less than R, like L is before R. If by any chance if L crosses R, means there is no element which is summing up to the target. But it is very clearly mentioned in the question that you will not be finding any such inputs where every test cases is going to have at least one answer for sure, right? I hope you have understood the code. Yes, please do try writing the same code in your LeetCode platform, right? And check with it. If you have understood the video, do not forget to like and leave your thoughts in the comment section. We have used three logics over here. One is brute force, the other one is hashing, and the other one is two pointers. We'll solve more questions on these algorithms, and also we'll try to understand more other logics as well, right? Do not forget to subscribe for more such videos. Thank you. Bye bye. Take care.